Okay, we're going to move on and do several of the next elements. The next one is carbon. Carbon has an atomic number of 6, which means it has 6 protons. They already gave you the mass number. The number of neutrons, remember, is mass number minus atomic number, so 12 minus 6, which happens to also be 6. And then the number of electrons is the same as the atomic number and the number of protons, for right now at least. Okay, I think I'm going to go ahead and fill in the rest of this chart, and then we'll do the part with putting the electrons into their energy levels. All right, nitrogen is next. Atomic mass rounds to 14. 7 protons, 14 minus 7, 7 neutrons, 7 electrons. Then we have oxygen, chemical symbol O, atomic number is 8, 15.99 whatever, rounds off to 16 for the mass number. There's going to be 8 protons because the atomic number is 8. The number of neutrons is mass number minus atomic number, so 16 minus 8, which also happens to be 8. And then electrons is the same as protons and atomic number, and that's 8. Fluorine is number 9. Chemical symbol F. The atomic number is 9. The atomic mass for fluorine is 18.998, which rounds off to 19. 9 protons, 19 minus 9, 10 neutrons, 9 electrons. Then we have neon, 10 protons, so that's the atomic number. 20.180 is going to round off to give a mass of 20. 20 minus 10 is 10 protons. 20 minus 10 is 10 neutrons, 10 electrons. Then we have sodium. All right, the chemical symbol for sodium is Na, and that's just simply because the word for sodium in some other language other than English, those abbreviations would make sense. So atomic number is 11, mass number rounds and gives us 23. If the atomic number is 11, then that's the number of protons. 23 minus 11 gives us 12 neutrons, 11 electrons. And then we have magnesium. Okay, so what I'm going to do is I'm going to pause and fill the rest of this part in, and then we're going to get to the electron arrangement. All right, we're going to start up here with carbon, where we left off. We have a total of 6 electrons that need to be put into energy levels. Remember, we put 2 in the first energy level, and then it's full. The other 4 can all fit in the second energy level. So I don't need the third energy level. There are 4 electrons in the outermost energy level, and that's going to be the second energy level. So there are 4 valence electrons. All right, nitrogen, they actually told you it's already 2 and 5. So those 7 electrons, 2 of them go in the first energy level. The other 5 go in the second energy level. Third energy level is not used, so it really doesn't even exist for this atom. Outermost energy level has 5 electrons, so there are 5 valence electrons. Oxygen, again, 2 electrons go in the first energy level, and then it's full. The second energy level, there are 6 electrons. We don't use the third energy level. The second energy level has 6. That's the outermost energy level, so that's the number of valence electrons. Okay, fluorine has a total of 9 electrons. We have to fill the first energy level. Remember, that's the energy level that is closest to the nucleus and has the least energy. Then the other 7 electrons will all fit in that second energy level. I don't need the third energy level at all. So there are 7 electrons in the outermost energy level, 7 valence electrons. Neon has a total of 10 electrons. The first 2 go in the first energy level. The other 8 will all fit in the in the second energy level. The third energy level is not used. There are 8 electrons in the last energy level, so neon has 8 valence electrons. All right, so far, if you noticed, we had hydrogen and helium only needing 1 energy level, so they only used the first energy level. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon all needed 2 energy levels, okay? So the second energy level for them was their outermost. All right, and starting with sodium, you're going to notice that we need that third energy level. Sodium has a total of 11 electrons. 2 electrons go in the first energy level. We can put 8 in the second energy level, but that's only a total of 10. That 11th electron has to be put in the third energy level. So the third energy level is the outermost energy level for sodium, and there is 1 electron out there. So sodium has 1 valence electron. Magnesium has a total of 12 electrons. 2 in the first energy level, 8 in the second energy level, for a total so far of 10. And then electrons 11 and 12 go in that third energy level. The third energy level is the outermost energy level for magnesium. And so magnesium has 2 valence electrons. For aluminum, they actually went ahead and told you how many in each. 2 in the first energy level, 8 in the second energy level. 2 plus 8, that's 10. So the last 3 electrons have to go out there in the third energy level. So the third energy level has 3 electrons, so there are 3 valence electrons for aluminum. Silicon, total of 14 electrons, 2 in the first energy level, 8 in the second energy level, and then the last 4 electrons go in the third energy level. That's the last energy level, so there are 4 valence electrons for silicon. Then we have phosphorus. 2 electrons in the first energy level, 8 electrons in the second energy level, and then the last 5 are in the third energy level. That's the last energy level that we need to use. And so there are 5 valence electrons. Okay. Now, before I end this, I want to show you a couple of things, so have your periodic table handy. Okay, I want you to notice a few things. First of all, let's look up here at hydrogen. Hydrogen has 1 valence electron. Lithium has 1 valence electron. And sodium also has 1 valence electron. If you look at the periodic table, hydrogen and lithium and sodium are all in the same column. Okay? The reason they're all in the same column is because all of those elements have 1 valence electron. Okay? So the way that the periodic table is organized is not random. Okay? All right, helium is actually an exception that we will address, not today, but it won't be too long before we talk about it. So helium, just put an asterisk and skip it for right now. But look at beryllium. Beryllium has 2 valence electrons. Go down here. Magnesium has 2 valence electrons also. You look on the periodic table, beryllium and magnesium are in the same column. Why? Because they have the same number of valence electrons. Okay? Look at boron with 3 and aluminum with 3 valence electrons. They're in the same column right here on the periodic table. Carbon with 4, silicon with 4. They're in the same column on the periodic table, okay? And then nitrogen with 5 valence electrons and phosphorus with 5 valence electrons, they are in the same column, okay? So, elements with the same number of valence electrons are in the same column, except for helium. Helium is an exception. But then let's look at rows. Hydrogen and helium are both only using one energy level. Hydrogen and helium, who only need one energy level, they are in the same row of the periodic table. Look at lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. They are using 2 energy levels, and all of those elements, if you notice, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, they are all in row 2. The elements that are using 3 energy levels, they are all in row 3 of the periodic table, so on and so forth. So there is some organization to the periodic table that's important. We'll talk in more detail about why helium is placed where it is shortly.